What's up, everyone? Today we are learning about the cosine ratio. So, as I previously stated, and as you may have seen in the videos or learned, we are talking about our trig ratios. It stands for trigonometric ratios. All the ratio is, just a reminder, is a fraction, one number over another number, or comparing two things. That's one way we could think about it. So we learned about our tangent ratio, which is our opposite side over our adjacent side. We learned about our sine ratio, which is our opposite side over our hypotenuse. And today we're going to talk about our cosine ratio. This is our last ratio that we're going to talk about. So we're going to be able to see some exciting things, and we're going to learn an easy way to remember all three of these, or one easy way that might stick into your brain. So let's get started with reviewing our sine ratio for our warm-up. It says calculate the value of sine p. Now, to remember, p is going to be called our reference angle here. And what we need to do, since it says sine, we have to remember that sine is equal to the opposite side over our hypotenuse. So we need to find our opposite side. So we're going to point our finger at P. We're going to drag it across the triangle till we hit a side. We hit side SN. SN doesn't have a value. But this is a right triangle, so we could find that side SN. We're going to say A squared plus B squared equals C squared. And if we might remember, this is called our Pythagorean theorem, where A and B are our legs of the triangle, and then C squared is our hypotenuse of the triangle. So I could fill this in. A is going to be my blank, right? That's going to be my variable. That's going to be SN. B is going to be 24 because that's the other leg of this right triangle. So we're going to have 24 squared plus or equal to C squared, which is 25 squared. So once again, we could bring out our calculator. As I always say in all the videos, the Desmos Scientific Calculator. There's an app for it, and there's also the website. So it's very useful. Desmos Scientific. I will link it down below in the video. But with that said, I'm just going to plug them in. We get 24 squared is equal to 576. So we have A squared plus 576 equals, and then we do 25 squared. And that's equal to 625. So then we have to subtract 576 from both sides. Get that A partially by itself. It's going to give me A squared is equal to, we just plug it into a calculator, 625 minus 576 is equal to 49. I don't even need a calculator for this. I know my perfect squares. And what we could say is the square root of both sides. This is going to cancel, and we're left with A equals 7. So that is the side of SN here. 7. So now we know our opposite side, right? Opposite. And then my hypotenuse is always across from our right angle. I'm going to make that green. Here's my right angle. My hypotenuse. We have our opposite, we have our hypotenuse, and then we'll label the adjacent side just so we have some practice. Adjacent, because it's next to P. They're right next to each other. Hi. They're neighbors. So now we have to do our opposite, which is 7 over our hypotenuse. So we could say that the sine of P is equal to 7 over 25. The question we have to ask ourselves, hey, self, can I reduce this? Answer is no. We can't divide 25 by 7, so it doesn't simplify, and that's the only number you could divide 7 by. So now we want to find the measure of angle P. And the way that we have to do this is by using our inverse, right? So we already have this ratio up here. So what we could do then is say sine inverse, and we're going to plug this in, of sine P. They'll cancel. Equals sine inverse of 7 over 25. All right? So then we get P, or the measure of angle P, is equal to, and we have to plug this into our calculator. So we're going to, if you're using the Desmos Scientific one, which I suggest, click function, you do sine inverse, and then you type in 7 divided by 25. You click enter, and it's going to give me, and we're going to round to second decimal place in this whole PowerPoint, 16.26 degrees. There's my answer. And now finally, we have to find N. And all we have to do is we know that P and N, they're the two acute angles in this right triangle. And when we have something like that, where there are two acute angles in a right triangle, we know that they have to add up to 90. So if we're working in reverse, all we have to say is 90 minus the one that we know, which is the one right here, 16.26. And we get our answer. So then we could say that this is going to give me, once again, let me plug into a calculator, 90 minus 16.26. And it's going to give me 73.74. Let me just write that. 73.74 degrees. And that's the measure of angle. And there's our answer. There's our warm-up. Right? This is all we learned about our sine ratio in our last lesson, probably the one that we learned yesterday. Or if you're watching this on YouTube, hopefully you've watched it already and now you know it. So let's get to today's lesson. And as I said, it's about the cosine ratio. So we're going to learn about the cosine ratio, the secant ratio, and the inverse cosine ratio. So this is going to be almost identical to my sine ratio lesson, right? So all our learning goals for that one, we're just substituting for now cosine, right? So we want to know the cosine ratio. We want to use it. We want to use it to find missing sides. We want to find the secant ratio. We want to use our inverse cosine ratio to find a missing angle, right? All those things. So first up, let's talk about the cosine ratio. The cosine ratio, or the cosine of an acute angle in a right triangle, is the ratio of the length of the side that's adjacent to the angle to the length of the hypotenuse. So it's our adjacent over hypotenuse, right? So if we're looking for our angle A here, that's our reference angle, right? What we want to do is we're going to label the sides. So we know how to find our one opposite. We're just going to draw that line across. And this is my opposite side. And I always suggest practicing this, right? Even like right now, I'm writing it on this slide. I know how to do it, but it's good practice to keep my brain fresh on what's opposite, hypotenuse, and adjacent. So opposite is across from our angle of reference. Across from my right angle is my hypotenuse. And that leaves us with our last side. My last side is going to be my adjacent side. Remember, these are sides, not angles. The things that are across from angles are sides. The things that are across from sides are angles, right? They go hand in hand when we say across from, right? So we have our opposite, we have our adjacent, we have our hypotenuse. So now we want to find our adjacent. Our adjacent's down here at the bottom. What's the name of it? AC. We're going to say AC over my hypotenuse, which is going to be AB. And there we go. We found our cosine ratio, or cosine of A, right? This is the cosine of A. It's AC over AB. Awesome. Now, just like all of our other ones, with our tangent, we had our cotangent, right? With our sine ratio, we had our cosecant. And now with our cosine, we have our secant. So the one thing that confused me was, which one is, what does secant go with and what does cosecant go with, right? Those were the things that really messed me up when I was learning about this originally, right? The way that I remember it is there's always a co, right? In each pair, there's a co. So sine, is there CO in sine? No. So then it's going to be cosecant. They pair off, right? They're the opposite of each other, right? And then cosine pairs off with secant because there's no co in that one, right? So cosine, secant, sine, cosecant, right? They each have one co. So our secant, like I said, is just the flip. So look, now it says length of the hypotenuse over length of the adjacent side, right? So once again, let's label it. We're using A. So it should be the same thing as our last one. Across, that's my opposite. Across from my right angle is my hypotenuse. And then right next to it, and the last side that we have here is going to be my adjacent. They're right next to each other. Hi, buddy. So now we want the length of the hypotenuse is going to be up top. So that's going to be AB. That's side AB over the length of our adjacent side, which is going to be AC. So it's just the reciprocal from our last one. So I'm just going to flip back a slide, right? Keep your eye on this little fraction we wrote here. On our last slide, notice it's AC over AB. Now this slide is AB over AC, right? The reciprocal, it just flips, right? The whatever was on the bottom comes up top. Whatever was up top goes to the bottom. That's the reciprocal, it just flips the fraction. And that's the relationship between our cosine and secant ratios. So let's now do some problems. Let's actually practice here, right? We're given these angles. This is very similar to our last lesson. We had to do something like this. So let's find our cosine ratio for both acute angles. So the first thing I want to do, and we're going to do this all in different colors. So my first one, we want to find these missing little chunks here. So remember, these two acute angles in this triangle have to add up to 90. So we could say 90 minus the one that's there, right? So we could say 90 minus 53. And that's going to give me 37 degrees. This is going to be a 37 degree. Switch my color. And we're just going to do this step for all of them straight across first. Here we have 48. That's one of my acute angles, and the other acute angle is missing. So once again, 90 minus 48, right? That's going to give me a 42 degree. So this is going to be 42 degrees. And last but not least, we have a 60 degree all the way down here, which some of us are like, no, this already pops into our head. This is a special triangle for us. This is our 30, 60, 90. So just let's do it just to keep up with the pattern. 90 minus 60 is 30 degrees. It's our 30. That's a special triangle right there. All right, now let's find our cosine ratio for both of these angles here. My first one, first we want to find cosine of 53 degrees. Right? The cosine of 53 degrees, once again, let's label our sides. Across from 53 is going to be 400. Actually, we're not going to label it because we have to do two different angles here. So I'm just going to state it. So 53 is our reference for this problem. So 400 is opposite. 500 is my hypotenuse. And 300 will be adjacent. So for cosine, it's adjacent over hypotenuse. We're going to get 300 over 500. Now, we want to simplify this. So I'm going to show you how to simplify this. We could divide both the top and the bottom by 100, right? Which is going to give me 3 over 5. But I want to make this into a decimal. So let's plug it into our calculator. We just do 3 divided by 5, enter, and it gives me 0.6. So there's our first value. I'm going to box this off like this so we keep everything nice and neat. And my next one, now we want to do it for this other angle, 37. We're going to get cosine of 37 degrees. Oops. Keep putting the degree outside the parentheses. There you go. So cosine of 37 degrees. Now, our opposite is 300. So our adjacent is going to be 400. So we get 400, and our hypotenuse should always stay the same. If you're in the same triangle, it should be the same. So if our hypotenuse was 500 here, we know it has to be at 500 here. Once again, we could divide both the top and the bottom by 100, right? Which is going to give me 4 over 5. So then I plug that into a calculator, and what it will give me is 0.8. Cool. Now let's switch colors. Click the wrong button. I apologize. Switch colors, do green, and we're going to kind of speed through a little more because we should be getting better at this stuff, right? So first, cosine of 48 degrees. Remember, it's adjacent over hypotenuse. So our adjacent for 48 is 335. 335. Our hypotenuse is 500. 500. Right? So once again, we need to try to simplify this, right? we want to try to simplify this. So what we could do is first divide it by 5 at least. Right? That's going to give me 67 up top. Divide the bottom by 5, it's going to give me 100. I'm going to say, hey, can we divide both of those by something? So let me think. I don't think we can. So it's just going to leave us with 67 over 100. When we divide the top and the bottom by 5. Then we just plug that into our calculator to get our decimal. So we get 67 divided by 100. It's just going to be 0.67. Ooh. 0.67. So looking at our values so far, we might start seeing some patterns showing up here, right? Start looking for patterns between what our angle measure is and what our cosine value is. So next one, cosine of our other acute angle, which is 42 degrees. And that's going to change now. Now our adjacent is 371 over 500, which is my hypotenuse. Once again, that doesn't change. Now notice our hypotenuse for all of these is 500, which is very nice, right? So we always know our hypotenuse here is going to be 500. Now we're not even going to try to simplify this one. We're going to go straight to the decimal to save some time. We get 371 divided by 500. That's going to give me a decimal of, and I'm not going to round this decimal, just 742. So 0.742. And our last triangle here, right? Let's find our cosine values. Cosine of 60 degrees is going to be my adjacent, which is 250. It's right next to it. We get 250 over 500. And what some of us might notice is this is just 1/2. So it's going to be, go put it right underneath, is equal to 0.5. Running out of space. So the cosine of 60 is 0.5. What's the cosine of 30 degrees? The cosine of 30 degrees, right here we have to do 433. 33 over 500. That doesn't really simplify, so we're just going to plug it right in. Our calculator. Oh, I'm sorry about that, guys. Keep hitting things. 433 divided by 500 is equal to 0.866. Right, and that's not even rounded. That's just what I get in my calculator. 0.866. Awesome. So let's look at our values and how they turn out here. So if we notice, if we go from our biggest angle, right? Our biggest angle here, 60 degrees, is 0.5, right? And then our second biggest is 53 degrees. It goes down to 0.6. Then we have 48, which is 0.67. And then we have 42, which is 0.742. And then we have 37, which is 0.8. And then we have 30, which is 0.866. So as we get closer to zero, here, it gets closer to 1. But all these are decimals underneath 1, just kind of like our sine, right? All our sine values were underneath 1. Same thing with cosine. All your cosine values should be under 1. If it's not, you have a problem, right? So those are a couple things we could keep in mind, and that's what all these angles and these values have in common. So now let's do the same thing, but we're doing it with our secant. So just a reminder, we go back, secant is SEC. That's a little 3-letter abbreviation for it. So if we're using a calculator, that's what you'll find on there too. So the secant value, SEC. All right, so let's look at these problems now with our secant. So one thing we notice is our secant, if we remember, now it's just our hypotenuse over adjacent. So a lot of these are going to be very similar looking to our first ones. So another thing we notice is if we go back to the same slide, these are all the same triangles. So let's just fill in our acute, right? So our first one's 37, 42, 30. So, oh, all right, forgot it. 37, 42, 30. So 37, 42, and last one is 30, right? So let's just find our cosecant of all of these angles. Now, I'm going to speed through these ones a little bit just to save time. So try to keep up. If you miss anything, just pause at the end and copy it all down. So our secant of 53 degrees is equal to our hypotenuse over adjacent, so 500 over 300. I'm not even going to simplify it. I'm just going to do the decimal. Now, all you have to do is 500 divided by 300 in your calculator. And what do we get? We get 1.6666 repeating. So we're going to put 1.66 repeating. Awesome. Next one. The secant of 37. Hypotenuse over adjacent, so it's going to be 500 over 400. Once again, plug it into the calculator. 500 divided by 400. And we get 1.25. Now notice already, both these are greater than 1. So that's one thing that's different than our cosine function. Next up, let me switch colors. So let's do our secant of 48 degrees, which is equal to our adjacent, our hypotenuse, so 500 again, over our adjacent, which is 335. So once again, not simplifying, just going to plug it into the calculator. And we get, I'm going to round it to the second decimal place, just like we have these. We get 1.49. Next up, we have the secant of 42 degrees. So that's 500 over the adjacent number to 42. Our adjacent side is 371. So once again, just plug it into the calculator. We get 500 divided by 371. And that gives me, once again, I've got to round it here to our second decimal place. It's going to give me 1.35. And last triangle. Secant of 60 degrees. It's going to be 500 divided by 250. This one's very easy. It's 2. Next up, the secant of 30 degrees. All right, my degree symbols here. A is going to be 500, and the adjacent side is 433. 33. I'll plug this one into the calculator. We get 500 divided by 433, and we have to round, so it's going to give me 1.15. So now we found our secant of all the angles in these acute triangles, right? And what do we notice? Let's find our biggest angle here. Our biggest angle is 60, right? And our secant is at 2. And then the closer we get to 0, so as we go smaller and smaller, our number gets closer to 1 again. So this is the same pattern we notice with our sine function, right? So with your sine and cosine, the closer the number gets to 90, right? Then the closer, right? Closer the number gets to 90. Actually, sorry. In our sine function, the closer the number gets to 90, the closer it gets to 1. In our cosine function, the closer the number gets to 90, the closer the cosine function gets to 0, or the cosine ratio gets to 0, right? But then both of them, the bigger the number, the bigger the angle gets, it's like the opposite, right? So our cosecant, which we did on the previous lesson, the bigger the angle gets, the closer it gets to 1. And then here, the smaller the angle gets, the closer it gets to 1. So for our secant, if we notice 30 is closer to 1, it's 1.15 than 60. Let's keep it moving. So what happens to the cosine and secant values as the angle measures increase? So once again, let's look at our angle measures. Here, our secant gets closer to 2, and here, our cosine gets closer to 0. So we could write cosine gets closer to 0. Secant gets bigger. We just could say, actually. Can't even say it gets closer to anything. We don't really know what it gets bigger to. It gets bigger. right? Because if we type in our, we can't even find our secant of 90, right? So it just gets bigger right now. So let's keep it moving. So for our first one, we already did this, right? For our 30, 60, 90, we already found the cosine of these, right? But let's just do it again, right? So cosine of, here's my 30-degree angle down below. I'm gonna mark it in purple. So the cosine of 30 degrees is going to be equal to my adjacent, 4 radical 3 over 8. So we're going to have 4 radical 3 over 8. And we could simplify this. Divide the top and the bottom by 4. Up top, they cancel. So it's going to leave me with radical 3. Down below, it's going to give me 2. And if we plug this into our calculator, I'll put the number right below it. We get equals, we should have seen this number already. So if I do radical 3 divided by 2, we've seen this number. It's going to give me about point, whoops, I'm about that. 0.866. This is a number that we had on the last slide for cosine of 30. Let's check out my cosine. Oops. Let's switch colors to green. Here we have our 60-degree angle, right? If we do cosine of 60 degrees, my adjacent's now 4, and my hypotenuse is 8. So just like our last one, the cosine of 60 is 0.5 or 1/2, right? Let me fill that in. Let me simplify the fraction first. Get 1/2. Then this is going to equal 0.5. I want to write it the same way we have it up top. Right? So cosine of 30 is 0.866. Cosine of 60 is 0.5. And for our other special triangle, let's switch color to red. We have our 45. We also know that this is 45, so they're going to be the same, right? All it is the cosine 45 degrees is equal to my adjacent, which is 8 over 8 radical 2. We can't leave that radical 2 in the denominator. So what do we have to do? Well, we know these 8's cancel first, right? So this is really like 1 radical 2. But then we have to multiply the top and the bottom by radical 2. So let's do that. And the radical 2's, it cancels the radical, so we're left with a 2 at the bottom. Up top, we just have radical 2, or square root of 2. When we plug this into our calculator, we do square root, radical, they mean the same thing. Divide it by 2, and it's going to give me, I'm going to round this to the 4. I know we've been rounding to 2, but it's just easier here. Actually, I'm going to round it to 2. Just kidding. It's going to be 0.71. All right, so 0.71. And this is the same exact thing as the cosine of 45, or the sine of 45. Sine and cosine of 45 degrees are exactly the same. It's like the middle point, right? Why? Because it's the middle point between 0 and 90, right? So that's why this works. 90 is the top we could go. We can't take sine, cosine, or tangent of anything bigger than 90 degrees. Because in our right triangles, we can't have angles bigger than that, right? So that explains it. Cool. So last but not least, let's go over our inverse cosine. So just like the inverse tangent and the inverse sine, we use our inverse cosine to find the angle measure. So if we know our sides and we could come up with the ratio, we can then plug that in and use our inverse cosine to find the angle measure. So that's exactly what all this is saying down here. So here we go. We have an example here. It says we have a triangle ABC. I'm just going to sketch it out, right? So it's going to be something like, let's just say, like this. Let's say that's my triangle, right? A, B. B is my right angle. C is here, right? It says the cosine of A is 2 over 7. I'm going to rewrite that here. Cosine of A, 2 over 7. One thing we know about cosine is my adjacent over the hypotenuse. Just like to do that so it's a reminder. So for cosine, our adjacent would be here. So we know that this is 2. My hypotenuse has to be 7. I just like filling that information in so I have it for my knowledge, right? But in order to find this missing angle, right, we got to get rid of that cosine. How do we do that? Well, we do the cosine inverse. We're going to write cosine inverse of cosine A equal to the cosine inverse of 2 over 7. All right? Here they cancel. And we're left with the measure of angle A. On this side, we just have to plug into our calculator. So we're going to go to click that function. If you're on the Desmos calculator, this is what you do. Click the function little abbreviation, click cosine inverse, click back to main, and you just do 2 divided by 7. And you click enter. And as you guys see, and once again, we're going to round to the, well, even if I round to the second decimal place, it's going to flip everything up. So we're going to get 73.4. There's going to be a 0 here. But if there's a 0 there, we don't really need to put it. So 73.4 degrees. And there we go. We found the measure of angle A. Next up, we want to find the measure of angle B. Well, we already have our triangle here. We don't know our cosine value yet, right? So we could write the cosine of B equal to what? Well, let's just remember cosine is equal to the adjacent over the hypotenuse. So B here is my reference angle. Across from B, if I draw my line across, this is my opposite. Across from my, let me make that green. Across from my right angle is my hypotenuse. Type. And that means the last side that we're left with here is going to be adjacent. Right? So with that being said, the cosine of B is going to be my adjacent, 16, over my hypotenuse, 18. So we could actually simplify this. Let's just do it to practice. If we divide the top and the bottom by 2, that's going to give me 8 over 9. And we could plug that into our calculator, right? If we want it as a decimal. Or sorry, silly me. What we want to do is rewrite this. We're trying to find the angle. So cosine of B is equal to 8 over 9. But if we want to find our angle, we got to get rid of cosine. We're going to write cosine inverse of cosine B is equal to the cosine inverse of 8 over 9. Here, cosine inverse and cosine cancel. And we're left with the measure of angle B is equal to, once again, we just plug this into our calculator. Function, cosine inverse, main, 8 divided by 9, enter. And we're going to round to our second decimal place again. And we get 27.27 degrees. 27.27 degrees. Awesome. So I just want to stop and remind you guys, if you are having any problems with any of this, be sure to ask your teacher, right? We're here to help you, not hurt you. So if you're my student, ask me. If you're Miss Harris's student, ask her. If you're someone else's student, ask them. Also, leave comments down below, and I'll get back to you as soon as possible. But please, ask for help if you need it. Ask for clarification if you need it. Don't be nervous because you're confused. I was confused when I learned this, and now I'm a math teacher, so that's how it is, right? Just ask for help. So let's keep it cruising. It says the measure of angle J is 90 degrees. AL is 8, and JL is 5. We want to calculate the measure of angle L. So let's sketch this triangle. So just make a right triangle. We know that this has to be J because it tells me that J is 90 degrees. So the only other thing that we have to do here is say which one's K and which one's L. And guess what? It doesn't really matter. It doesn't really matter. So we're just going to say K and L. Another thing we know is that AL is 8. JL is 5. So we want to figure out what is the measure of angle L. Well, lucky for us, they told us the opposite, the adjacent, and my hypotenuse. And that's exactly what we need, because if we want to find the cosine of something, it's adjacent over hypotenuse, like we've been saying. So what can we say? We could rewrite this as cosine of L is equal to 5 over 8. That's already in simplest form. So if we want to get rid of that cosine, we'll say the cosine inverse of cosine L is equal to the cosine, that's an N, not an S, cosine inverse of 5 over 8. Cosine inverse and cosine cancel. We're left with the measure of angle L is equal to, and all we do, once again, plug it into a calculator. Cosine inverse of 5 divided by 8 is going to give me, whoa, whoops, sorry about that. Spoiler alert. Going to give me 51.32 degrees. That's round it. Awesome. So here we go. Once again, we did another cosine inverse. Now, like you saw, let's go to our word problem. So here we have firemen. They're climbing a 65-foot ladder to the top of a 56-foot building. They want to calculate the distance from the bottom of the ladder to the base of the building and compute the measurement of the angle formed where the ladder touches the top of the building. There's two things they want us to do here. Calculate the distance from the bottom of the ladder to the base of the building. They want to calculate this distance here, right? And we could do that by using our Pythagorean theorem, right? So once again, we could say a squared plus b squared equals c squared. And we know in this little triangle that we have here, right here, going up here and down here, that triangle, it's going to be my A, B, that's a 5, I meant to put B, right? B and C. So we could say that A squared, that's what we're looking for, plus B is going to be 56, because that's the height of the building, squared equals 65 squared. That's my hypotenuse. Right, so then we just square our numbers. We get A squared plus 256 squared in our calculators. Going to give me 3136, so 3,136 equals 65 squared, which is going to give me 4,225. We subtract 3136 from both sides. They cancel here. We're left with A squared equal to 4225 minus 3136 is going to give me 1,089. And last but not least, we take the square root of both sides. And the square root of 1,089 is equal to 33. So we know that A squared equals 30, or sorry, A is equals to 33. We got rid of the square. All right, so we could fill this in here. This little section here is 33. So the second thing they want us to do is they want to, the second part here, it says, and compute measure of the angle formed where the base ladder touches the top of the building. So the ladder here, they want to do this angle here, right? So we want to do that using our cosine, right? So this is 56. So that's our adjacent, ADJ, and my hypotenuse. So the cosine of, let's call this x, is equal to 56 over 65. But if I want to find the angle measure, we then write this as our cosine inverse. So we'll say cosine inverse of cosine x is equal to cosine inverse, what we do to one side, you have to do the other, of 56 over 65. Here, cosine inverse and cosine cancel. We're left with x equals, and we plug this into our calculator. And we get cosine inverse of 56 divided by 65. Oops, missed a number. 5. And it's going to give me, round it to the second decimal place, 30.51 degrees. There we go. We found our second answer here. Awesome work. Once again, if you're confused or have any questions, please let me know or your teacher know. And let's do another problem we got here. This one's a little longer. So let's make sure we follow along. First, let's read it. It says Diane is training for a charity bicycle marathon. She leaves her house at noon and heads due west, biking at an average rate of 4 miles per hour. At 3 p.m., she changes course to the north 65 degrees west, as shown. Right? Label the diagram and determine bike's distance from Diane's home at 5 p.m. So this one is pretty hard, right? So if we don't fully follow along, it's okay. I understand. I'm going to talk us through it. So it says she's going 4 miles per hour. And at 3 p.m., she changes her time, right? She leaves at noon. So if at noon to 3, that's 3 hours. And she's going 4 miles per hour. Well, how many miles does she travel? Let's do some scratch work. From noon to 3 p.m., that's 3 hours. Times 4 mph, right? 4 miles an hour is going to give me 12 miles, right? So she travels 12 miles when she heads straight west, right? So she starts here, going west, she travels 12 miles. This distance from here is going to be 12. She then changes course and she goes up this way at a 65-degree angle, and she travels there for 2 hours, right? So we got 2 hours at same speed, 4 mph. That's going to give me 8 miles. So this diagonal line here is going to be 8 miles. So we have to try to figure out what information we're given here and what can we find out, right? So what we need to do then is actually label a couple of these things, because we have to find out certain things first, right? So we're going to use 3 variables, X, Y, and Z. And we have to find them in that order. First, we're going to say that this little section here is X. We're going to call this section Y. And this long section, the distance that Diane travels, is going to be called Z, right? So first, we need to find X. But there's one more piece of information we need to know. If we look here, we're going to have a right angle. We have 65 here, and we want to find this missing angle right there. So if we want to do that missing angle, we could say that we know they're going to be a 90-degree angle. So we say 90 minus 65, and that's going to give me 35. Or sorry, 25. Well, 25 degrees. Right here is 25 degrees. So first, let's find X. Well, if we look in this right triangle here, 25, we want to find using our 25 as our reference angle. So X is adjacent. Y is going to be opposite. And 8 is my hypotenuse, right? So with that information, let's find X first. Right? So if we find X, we can now say that this is the cosine of 25. I'm going to say the cosine of 25 degrees is equal to my adjacent X over my hypotenuse of 8. And what we have to do is plug this into a calculator. So we're going to plug the cosine of 25 into a calculator. We're going to type cosine 25, enter, and it's going to give me, we're going to round to the second decimal. It's going to give me 0.91 equals X over 8. And we have to get rid of the X or the 8 here. So we're going to multiply both sides by 8. And that's going to give me X on my right side. And here we just multiply these two numbers. 8 times 0.91. It's going to give me 7.28. That's important. So X is equal to 7.28. Now let's find my next value. My next value is going to be Y. And Y is now my sine, opposite over hypotenuse. So sine of 25. So we could write, lost my, change color, blue. We'll say sine of 25 degrees is equal to y over 8. My opposite over hypotenuse. Once again, plug the sine of 25 into our calculator. We say sine 25 degrees, and we're going to round to our second decimal again. It's going to give me 0.42. 0.42 over y 8. Once again, multiply by 8 both sides. And we're going to get, on my right side, y, and on my left side, we do 8 times 0.42. That's going to give me 3.36. All right, so right here, we're going to put 3.36. Now what we could do is, if we notice, we have one big right triangle. On the outside of this whole diagram here, we have one big right triangle where my height is 3.36 and my base is 7.28 plus 12. So let's find the value of that base real quick. Really just these chunks together. So on my scratch work, we do 12 plus 7.8. So in my calculator, we say 12 plus 7.28, and it's giving me 19.28. And what we have here is we could use our Pythagorean theorem again. So we're going to say a squared plus b squared equals c squared, where my a is going to be 3.36 squared plus my b, which is 19.28 squared, equals my c, which is going to be z squared. So finally, we just square these. We do 3.36 squared. And that's going to give me, we're going to round 11.29 plus 19.28 squared, which is going to be bigger. It's going to be 371.72 equals z squared. Now, I'm just going to rewrite this here. We get z squared. Add these two together. Right? So 371.72 plus 11.29. That's going to give me 383.01. Finally, we take the square root of both sides. We're almost done. We get z equals square root of 383.01. And it gives me 19.57 miles. And that is the answer. That's how far Diane went from noon to 5 p.m. She went 19.57 miles. Awesome. And that is the end of the lesson. Like I said, some of this may be confusing, right? Well, we're going to practice more. We'll iron out all of the wrinkles. Don't worry if you don't fully understand it yet. But if you do, or if you're understanding the earlier, if you're misunderstanding the earlier stuff, ask for help. This later question, like the last one we did, is going to be more difficult. If you don't fully understand it, that's okay. But the early stuff of just finding a missing side, ask for help on those problems. Let us know what we could do to help you. And until next time, peace out, everybody.